Welcome back to the Privacy Report. We're here to help you navigate the digital world and, crucially, stay in control. Today, we're looking under the hood at something pretty fundamental that's changing how data gets stored and secured. It's called object storage.
Yeah, it's a bit of a quiet revolution, but it's massive.
Yeah.
For years, everything was based on, the standard file system. Folders, drives, paths.
The C drive stuff.
Exactly. And that structure, well, it's really starting to creak under the weight of modern data. Think of massive scale, distributed systems.
It just wasn't built for petabytes scattered everywhere.
Precisely. The old filing cabinet model, it falls apart when you're dealing with backups or archives across potentially thousands of servers.
So, okay, we've got this explosion of data. It's everywhere, and we absolutely need it to be secure, resilient, private. And the answer that's really come out of the cloud era and is now kind of defining things is object storage. You're saying it changes the game for backups, archiving, even digital sovereignty.
It really does. It's become the architectural backbone for modern digital resilience. It's that important.
Okay, interesting. Before we dig into how it works, just a quick reminder for everyone listening. You can get takeaways from our chat sent to your inbox by subscribing to our newsletter. Find it at theprivacyreport.net. All right, so let's unpack this. If we're ditching the C documents folder structure, what does data even look like in this new world?
It's a different way of thinking. Object storage basically says, forget physical drives, forget nested folders. Instead, every single piece of data, whether it's a tiny text file or a huge video archive, it's treated as a standalone object.
An object.
Yeah, an object just floating in this enormous flat space, like a giant pool of data, not a structured cabinet.
Okay, that sounds less like browsing folders and more like searching a database.
That's a great analogy. It's built for finding things at scale, not clicking through directories. And every object has three key parts that make this system function.
Right, what are they?
First, obviously, there's the data itself, the actual
It
content.
makes sense.
Second, and this is where it gets really powerful, is rich metadata.
Metadata. I usually think file name, date created. What does rich mean here?
It means the object carries its own context with it. So yes, the basics like name and timestamp, but also maybe custom labels like its encryption status or this specific GDPR retention policy it needs to follow.
Wow.
Or the owner, audit tags. Basically, the data can carry its own rules.
So the data itself knows how it should be treated, like how long it needs to be kept, how secure it needs to be,
Exactly. Self-aware is a good way to put it. And the third piece is a unique identifier.
instead of cfolder myfile.txt.
Right. No messy physical path. Each object gets a permanent, unique ID. Often it's something like a cryptographic hash or a UUID. That ID is its address in that giant data pool.
Okay, so no folders to click.
Right.
How do you actually get your data back then? It must be all code-driven.
It's entirely API-driven. You don't browse. You send a request using an API, an application programming interface.
The language computers use to talk to each other.
Pretty much. And that API access is the key. It unlocks massive horizontal scalability. The system can spread across thousands of servers, maybe even different continents, but to the user or the application, it just looks like one single seamless storage system.
Right, that API hiding the complexity. And that connects directly to why this is so good for backups, doesn't it? We all know buying one massive expensive server, vertical scaling, just doesn't work long term.
Yeah, vertical scaling hits a wall and it gets incredibly expensive. Object storage shines because it scales horizontally. Meaning, when your data grows, you just add more storage nodes, more standard, often cheaper, hardware gets added to the pool. You don't need to re-architect everything.
Like adding more bricks to a wall instead of trying to make one brick bigger. We see this with Amazon S3, Wasabi, but also self-hosted stuff like Minio.
Absolutely, it applies across the board.
Okay, let me push back a bit though. If I'm, say, a small business and I just need to back up a few terabytes, isn't just buying a big external hard drive simpler and maybe cheaper than setting up this, distributed object thing?
That's a fair question. It seems simpler upfront, maybe.
Yeah.
But relying on one single physical drive, that's like putting all your eggs in one very fragile basket.
True. One drop and it's gone.
Right. And while horizontal scaling sounds complex, it often uses inexpensive standard hardware. So the cost per gigabyte, especially as you grow, can be much lower. But more importantly, it's about durability. Real resilience.
Durability. Okay, that's paramount for backups. If my data is spread across all these nodes, how do I know one disk failing won't just kill my archive?
That's where the system gets clever. Object storage manages redundancy automatically behind the scenes. It uses techniques like replication, just making copies, or much more efficiently, something called erasure coding.
Erasure coding sounds technical. What's the gist?
Okay, think of it like this. Instead of making, say, 3 full copies of your 10 GB file, which uses 30 GB of space erasure coding, breaks a file into smaller chunks. Then it calculates and adds some extra parity chunks based on math. The cool part is, if you then lose several of the original or parity chunks, maybe a whole drive fails, or even 2. The system can mathematically rebuild the original complete file from the chunks that are left.
Ah, I see. So you get strong protection against failures without needing triple the storage space. It's smarter redundancy.
Exactly. Efficiency and durability rolled into one. And because it's all API-driven, this allows for amazing automation in backups.
How so?
Well, tools like Borg or Restic, they're not just simple backup programs anymore. They're built to talk to these object storage APIs. They can handle versioning, tell the storage to replicate data, manage encryption policies, all programmatically without you worrying about the physical hardware underneath.
Right. The software tells the storage what to do, and the storage figures out how.
And that separation of the management, the logic from the physical disks, that loops back to cost too.
How does that work?
It enables something called data tiering. You can set policies like, if this data hasn't been accessed in 90 days, move it to cheaper storage. And the object storage system can handle that automatically, shifting older archives to slower, much less expensive media, maybe even within the same overall system, all without you needing to change your backup process.
Okay, that's clever. Optimizing cost and performance automatically. Let's shift to the core topic here. Privacy and security. Does this fancy architecture automatically make my data more private?
It gives you the potential for much greater privacy and control. But, and this is key, you have to use the tools correctly, object storage supports encrypting data when it's stored. Encryption at rest. That's good. But crucially, it also supports client-side encryption.
Client-side, meaning I encrypt it before it even leaves my computer.
Exactly. And that is the foundation for what we call trustless backup.
Trustless, meaning I don't have to trust the storage provider?
Precisely. If you encrypt the data on your end, using your own keys that you control, then even if you store it on a huge third-party cloud service, all they hold is scrambled nonsense, meaningless ciphertext. You retain the actual control, the sovereignty over your information. They just provide the space.
That feels like a really important distinction for privacy. Now let's talk ransomware. We hear about immutable storage all the time in security circles. Why is object storage plus immutability such a big deal?
Immutable buckets are, honestly, probably the single most powerful security feature in object storage today. It means write once, read many, or worm.
Write once, read many, so once it's written...
It cannot be changed, it can't be overwritten, it can't be deleted for a set period that you define beforehand.
Like a digital time lock box, an attacker can't mess with it.
Exactly. That gives you 2 huge benefits. First, security. Ransomware can encrypt your live systems, but it cannot encrypt or delete your immutable backups. Recovery is basically guaranteed.
That's massive.
And second, compliance. Many regulations, like GDPR or financial rules, demand that records are kept unaltered for specific periods. Immutable storage nails that requirement. Cybersecurity teams are increasingly mandating worm storage for this reason.
It seems essential. But what if I don't want to use a big cloud provider at all? Can an individual or maybe a smaller organization get this kind of protection but keep everything physically in-house? Maintain total control.
Absolutely. That's entirely possible. You can achieve full data sovereignty by self-hosting your own object storage system. There are great open source platforms like Minio or Ceph that essentially let you build your own private Amazon S3 compatible cloud.
On my own servers.
On your own hardware, in your own data center, even in your server rack at home if you wanted. You get the same resilience, the same API-driven benefits, but with complete physical and digital control.
That's really empowering. Okay, but let's bring in the reality check, the caveat. We've talked about how this tech enables control, where's the risk, how do people undermine its potential.
The caveat is critical. Object storage isn't magic security dust. It's not inherently private just because it exists. Its actual security and privacy depend entirely on how you configure it. The biggest risk, relying on the provider's defaults.
Just uploading files without thinking.
Yeah. If you upload sensitive data unencrypted, if you rely solely on the cloud provider's basic access controls, you're placing all your trust in them. To really get the control we've been discussing, you have to take responsibility. Use client-side encryption. Set up strong granular access policies. Be mindful of where the data physically resides.
So the technology provides the shield, but you still have to actively hold it up and point it in the right direction.
Well put.
Okay, let's wrap up with some real-world examples. Where are we seeing this model take hold beyond just the huge tech companies?
Oh, it's spreading. We see smaller organizations, even journalists or activist groups, using self-hosted tools like Minio to build their own encrypted, geographically distributed object stores, basically creating their own private, super resilient clouds to protect sensitive work. And then, on the enterprise side, you see lots of hybrid cloud strategies. Companies keeping some data on-premise but replicating critical backups or archives to S3-compatible storage in the cloud, specifically for compliance or disaster recovery, often using those immutable features.
So the common thread seems to be this move away from relying on a single point of failure towards decentralized, automated, resilient data protection.
Yeah, the focus shifts. It's less about where did I save that file, and more about how do I ensure this object is always available, always verifiable, and always under my control.
Which leads us to a final thought for you listening today. Maybe the backup of the future isn't just about having a copy. Maybe it's really about using this kind of architecture, using strong encryption, to guarantee that your copy stays yours, unequivocally under your control no matter whose physical server it happens to sit on. That's our time for today. Thanks so much for tuning into the Privacy Report. If you found this useful, please do like and subscribe wherever you get your audio. It really helps others find the show.
And keep thinking about control and transparency in your digital life. Always ask where your data, your objects really live.
And finally, a quick disclaimer. This discussion was produced with the assistance of AI.